Welcome to the 2020 Olympic Games.
On your mark, get set.
Wait! The social distance.
On your mark, get set.
Go!
And now for the 100-meter crab walk. Crab walkers, to your mark. Set. Go!
Okay.
Oh my goodness. New world record! And now for the 400-meter somersault race. Somersaulters, to your mark. Set. Go! Oh my!
Now from Kenya. Now from Switzerland.
And now from Cuba.
From North Korea. Hi, Rush, please.
From the United States of America, world record long jumper, Robert Nyson.
Let the e-learning begin. Happy Wednesday, everybody. And I'd just like to give a big thanks to 3 of the people in the video were our children, and the other 3 were friends and roommates of Noah's from Bethel. And you know, I just can't compete with that. A couple of them actually ran track at Bethel, and not only did they run track, they were like All-Americans in the NAIA. And one, in fact, was also All-State when he was back in high school for Northridge. And so All-State in track. You think I can compete with that? I can't compete with that. I'm telling you, those guys, they got more miles on their treadmill than I have on my car. And like, whew. And so, but rest assured, the only jogging we're going to do today is I'm going to be jogging your memory on some math ideas. And so make sure you take attendance on the form here and get that done right away. A couple of you are forgetting. You'll forget on a Friday or you'll forget on a Wednesday. And so get that done. It makes it a lot easier on me. Once you get that done, we're ready to start the notes. Algebra today. Remember Monday we graphed compound inequalities. We talked about disjunctions. We talked about conjunctions. We talked about conjunction as an and, disjunction as an or. And today we are going to talk about absolute value inequalities, and we're going to use those words disjunction and conjunction again. And so today's homework is page 485, 13 to 39 odd. Again, they're all odd, and you have to graph number lines. A couple of you didn't graph number lines. I want to see the land and the gore. And so we're trying to get that idea in your head. So keep working on your warm-ups on Khan Academy. No new ones, just the 3 for this week, and go back and do the old ones. And then also your logic problems. Some of you already sent them in to me, and that's very good. And so we want to get that done. And so on the notes today, this is notes number 122. We're going to talk about absolute value inequalities. And so we're just going to go through and kind of explain some techniques on this and build some ideas in your head. And so if we say the absolute value of x is 3, what values would give you the absolute value equals 3? What would those be? What would we get? Cole? Yes, the absolute value of 3 is 3. See this? You could plug a 3 in, and the absolute value of 3 is 3, so we put a dot there. Is there any other numbers we could take the absolute value of and still get 3? Cody? Yeah, -3. The absolute value of -3 is 3. And so both of those would work. And that's it. Well, that wasn't too tough. And why do I need to graph it on a number line if there's just 2 answers? Well, you wouldn't. I mean, you could just write x equals plus or minus 3 like we normally do with the fancy braces. Yeah, you try to make one of those with a mouse. They'd look about as crazy as that one just did. So, but normally on our answers, there's going to be just more than 2. But you're going to graph all of them. And so we do that. But the technique is, when we read this problem, the absolute value of x equals 3, the technique is we write what's inside the absolute value, and we say that equals 3. But an equal is an or. X equals 3, or x equals, and then what we're going to do is we're going to change this to the opposite sign, equals -3. And see, x equals 3 or x equals -3, and or makes a gore. There's a hole in the middle. And so it's this or this. And so we have that. Now let's look at this. Let's do the exact same problem and say the absolute value of what numbers are less than 3? Well, you might say 2 and 1 and 0. And then you might be tempted just to say, well, it goes from there down. Well, Mr. Nice would actually go from the open dot of 3 down. You know, x is less than 3. But would all those values work? Are all of those absolute values less than 3? Joe? Yeah, see, -4 isn't going to work. The absolute value of -4 is 4, and that's bigger than 3. So there comes a stopping point. And so we don't just want to guess around at all the answers, especially the last ones. Guessing around at those, you're in serious trouble. Or no, Mr. Nyson, it's odd. So I perfectly got them all. You know, a miracle happened. And I can get the answers without even showing work. You know who you are. You know who I'm talking to. And so we don't just want to be guessing around. We want to learn a technique. Well, the technique is this. Read this problem to me. Maddie? Yes, the absolute value of x is less than 3. And what we're going to do is say less than land. Less than will always be an and it's going to graph land. So if we say x is less than 3, and it is important on your homework, I want to see these ands and ors on every problem. Less than and then, oh man, we wish we could play some baseball and watch some baseball. We're going to do the double switch on every one of these problems. We're going to flip this, and we're going to take the opposite of this. So the first thing you do is you just write it down the way it is. And then the second thing is you do the double switch. X is greater than -3. And we're going to graph this. X is less than 3 and X is greater than -3. Well, are these open dots or closed dots, Hannah? Yeah, open. Yeah, we wish stores were open for business. Oh, too many closed dots these days. But open at 3 and open at -3. Okay? And if I am less than 3, I'm going this way. If I am greater than -3, I'm going this way, but it's an and. I have to be in both. Well, the quick way to do it is just say less than and makes land. Land ho! There we go. A little island. And so we have that. Okay? And so let's take a look at the next one. Here. That one, first one was x equals, and that was an or. The next one was the absolute value of x is less than land, and it's going to make land. This one, though, when we graph this, read this one for us. Aiden. What? Your pencil broke? Gotta give you a second. Okay, you ever hear the joke about a broken pencil? It's not. You don't need to hear it. It didn't have a point anyways. And so, okay, you ready, Aiden? The absolute value of x is greater than 3. And so what you do is you isolate the absolute value, get it by itself, and so x is greater than 3. But what we're going to do is greater than makes an or. Greater than is always an or. And that's going to graph a gore. Gore. Greater or gore. And so when you write this down, you write it down, then you write the word or. And then you're going to do the double switch. You're going to flip the inequality sign, and you're going to take the opposite of the answer. And so this answer is this. X is greater than 3, or x is less than -3. So Hannah, are these open or closed? Yes, they're still open. Good job. And so we're going to go greater than 3, and then we're going to go less than -3. Greater or makes gore. And so there we go on that one. Okay? And so let's take a look at this next column where this is your homework towards it's not, you got more to think about. Okay? So let's take a look at this next column. Next column. Scrolling back up. Big mistake people make is they think they're just going to do the double switch. They're going to read this and go less than and land, and they're going to write less than 15 and greater than -15. But why would that not make any sense? And you better not be writing this down. Why wouldn't that make any sense? Danielle? Yes, because you don't have the absolute value by itself. That only works when you have the absolute value isolated, and then you can say what's inside it is greater than this and less than this, or greater than this or less than this. And so what you first have to do is isolate the absolute value. You got to social distance everything from the absolute value. Get it to the other side. You know, and so like in that race we were running, I said we need to social distance. Of course, I distanced by giving myself a head start. The others weren't that smart. And so we're going to add 1 to each side. And we're going to get 4 times the absolute value of x is less than 16. And then we're going to divide by 4. And see, now we have everything social distanced from the absolute value of x. And so the absolute value of x is less than 16. Well, what are all the values? Whoa, I forgot to divide that side by 4. Oh, we almost got the emails coming. Mr. Nyson, you made a mistake. You forgot to divide by 4. It always happens in algebra. I don't know. My mind's on the next thing. It's probably because I didn't show the step. See, that happens to you too when you don't show the step. So if we read this, what would this read, Lauren? Yes, absolute value of x is less than 4. And Judah, less than is land. And so we're going to write x is less than 4. And we're going to do the double switch. We flip the sign, and we make it the opposite. And so these are open dots, just like Hannah said, because there's no line underneath. And if you do your warm-ups in Khan Academy, that will review open dot, closed dot. And then I can tell who's having a little trouble. It took me 3 attempts. Must mean we're getting a little confused on closed dots and open dots. And if it's an and, Cam, an and is a land. And so we're graphing land in the middle. And that's what you do. Less than and land. Greater or gore. And you can't miss these. Let's do the next one. Here we go. Is this one already isolated the absolute value? Yes, it is. So we are ready to do the double switch. We're going to do 5x minus 2 is greater than or equal to 8. Greater, Elijah? Greater, gore. Yes. Good job, Elijah. And so then we do the double switch. So we do 5x minus 2. It was greater than or equal to 8. Now it's going to be less than or equal to negative 8. And here you have to solve each of them individually. You can't just solve one and change the sign, because here, you add 2, you get 10. Hopefully I don't make a mistake. Otherwise, expect an email. I'm not remaking the video. And divide by 5 and you get 2. So that's x is greater than or equal to 2. Or, but don't be lazy and think, well, there's a 2 here, and I'll go this way. Hey, boo-boo. If it's an or, I'll just put a negative 2 and go this way. I'll skip some steps. Oh, but then the ranger might get us. And so we actually have to show steps. When you add 2 to negative 8, you don't get 10. And you don't get negative 10. What do you get? Abby? Yeah, you get negative 6. And then when you divide by 5, you get negative 6/5. Well, if you're having a little trouble figuring out where negative 6/5 is on the number line, it's x is less than or equal to negative 1 1/5, negative 1.2. Well, negative 1.2, 1/5 is going to be right about, whoa, make your dot big enough, your dot covers the whole thing. So negative 1 1/5 is right here, and we're going less than that. And notice, less than, greater than, gore, makes a hole in the middle, and those are all the values. You could pick anything right here. I could pick negative 3, plug it in, and it works. I could pick negative 4, plug it in, it works. But if you pick 0 and plug it in, it don't work. Anything that we don't graph doesn't work. Anything that we do graph does. Okay? And so we got the next problem. Put myself over here. This one, is the absolute value already isolated? Preston? Less than makes Jordan land. Yes, very good. And then, Jack, what are we going to do? Yeah, the double switch. So we write 2x plus 5. We're going to flip this to a greater than sign. And it's the opposite, but see, it's the opposite of the whole side. It's not just the opposite of one number. It's the opposite of the entire side. So this one, we subtract x and we get x. And then here, what are we going to do? Annabelle? Yeah, subtract 5 and you get negative 2. I don't like writing all these steps with a mouse. If I had a pencil, it'd be fine. So x is less than negative 2. And this one, if we distribute the negative, we get 2x plus 5 is greater than the opposite of x minus 3. So what would you do on this one first? Ethan? Yeah, add x, you get 3x. Subtract 5, you get negative 8. Divide by 3, and you get negative 8/3. Which Bree is? Yeah, negative 2 2/3. So we're going negative 2 2/3 is right here. That's an open dot. We're going greater than negative 2 2/3, and we're going less than negative 2, and it's an and guess what? It graph land. Now, is that a tiny little answer? Well, you might think so, but how many numbers are actually in there, Dominic? Infinitely many. There's plenty. You can, just even if you're given that amount, you could say numbers for the rest of your life, and you still have infinitely many numbers left to say. Okay? So, then, towards the end of your assignment, there's a couple problems that you don't actually have to solve if you just think. And if you actually solve them, it doesn't work with less than and land, greater than or gore, and I don't know what's going on because I forgot common sense. So we're going to take a look at these. We're going to do these last two, and then we'll start the homework. On these last two, inequalities you wouldn't have to solve. But if you become a robot, you would do this. You'd say, well, 3x minus 5 is greater than negative 8, and greater or less than negative 8. And if you actually solve these, you get 3x minus 5 is less than negative 8, and I'm going to try to skip a bunch of steps. If you add 5, you get negative 3, and if you divide by 3, you get negative 1. And so this would be x is greater than negative 1, or, and then here you'd have 3x minus 5 is less than, I didn't do the double switch, is less than positive 8. So then when you add 5, you get 3x is less than 13, divide by 3, and x is less than 13 thirds. Well, when is x greater than negative 1 or less than 4 1/3? Well, that's all the time. But did I really need to do all that work to realize it was all the time? What is that, Jack? Yeah. Isn't the absolute value always going to be greater than a negative number? Yeah. So why did I do any work? Look at this problem. The absolute value of 7 minus 0.25x is less than negative 3. When will that happen? When will the absolute value of that quantity be less than negative 3? Colin? Yeah, never. When is the absolute value going to be negative? It's never going to be negative. It's not negative. It's either going to be 0 or it's going to be positive, but it's never negative. And so the answer to this one is not possible. Okay? And so you didn't really need to show work on that one, but all the rest you do. And so on your homework tonight, we're doing the odds. And so we're starting at problem number 13. And what I want to see from you is I want to see m minus 6. I want you to write m minus 6 equals 8, or equal is an or. And yes, you can flip an equal sign. Oh, but it still looks like an equal sign because it's symmetrical. Is that why they did that? M minus 6 equals negative 8. And solve both of those. And so you will get, what, 14 and negative 2. For problem 15, you're going to write this, and you're going to write equals 5, and then you're going to write this, and you're going to write or, you're going to write x plus 3 equals negative 5, and then solve them both. Problem 17, you're going to write r is less than 2.5, less than is land, yes. Less than and makes land. And then you're going to write r is greater than, do the double switch, negative 2.5. You need to graph it on a number line. 0, 1, 2, 3, negative 1, negative 2, negative 3. Open dot, 2.5, negative 2.5. And in between, less than and graphs, land. 19, greater or makes gore. Greater than 8 or less than negative 8. Less than and makes land. Less than or equal to 2. Greater than or equal to negative 2. But when you're solving this, remember this is a plus negative 1p. And so when you subtract 6, but then when you divide by negative 1, you're going to flip the sign. It'll still work. Trust me. Same thing here on 23. There's a plus negative 1 in front of the a. So you're going to set this greater than or equal to 4 or less than or equal to negative 4. Then you'll add 2 to both sides and you'll divide by negative 1. Flip the inequality sign. On 25, you do not say greater than or equal to 7 or less than or equal to negative 7 because you have not. Notice this is the B section. That means you better be careful and solve for the absolute value first. So you just add 2, get 9, divide by 3. And you're going to get the absolute value of s is greater than or equal to 3. And then break it apart and do the double switch. And so greater than or equal to 3 or less than or equal to negative 3. Same thing for 27. First get this by itself. 29, this is a plus negative 3. Get this by itself. 31, this is a plus negative 1. Oh my. So you first want to subtract 6 and get negative 1 times the absolute value of the quantity of 2 minus p is less than or equal to negative 2 when you subtract 6. And then when you divide by negative 1, you're going to have to reverse the sign. And so when you divide both sides by negative 1, you're going to get the absolute value of 2 minus p is greater than or equal to 2. And so you thought it was a less than and make land when you originally look at the problem, but it's because the absolute value is not social distance isolated, and it's really going to be a greater than or makes gore, greater than or equal to 2 or less than or equal to negative 2. 33, solve for the absolute value of a. Distribute the 2 or divide by 2 first. Solve that, and then it's going to be less than and makes land. 35, you're going to set this equal to y over 2, or you're going to set it equal to the opposite of y over 2. These are C problems. You can see that they're hard. This one, you have the absolute value of quantity t minus 4. It's greater than t minus 4, or it's going to be less than the opposite of t minus 4. And you'll solve that. Greater or makes gore, maybe. But it's a C problem. I don't know what's going to happen. And so this one, greater or, you have greater than that, or doing the double switch, you're going to have less than or equal to the opposite of this. Okay? So we gave you lots of hints. It's always obvious who watches the video to the end, because I know you've listened to the hints and you write them down. Plus, it saves you time because you know what you're doing. And so make sure you send me your homework right away. Don't wait till Sunday night. You know, he who hesitates is lost, but a stitch in time saves 9. And so remember that. And so give me your homework. I look forward to receiving it. You email me. We enjoy talking with you. And so hopefully you enjoyed the video today. And so have a great day. We miss all of you, and hopefully soon we'll be able to see each other. Okay. Bye-bye.